All right, here's questions 5 to 7. The student council sells lollipops for 10 cents each. They pay for 4 cents for each lollipop and spend $10 to advertise the sale. P represents the student council's profit in dollars, and N represents the numbers of lollipops sold. Right, so let's begin. Let's create our formula. We know that it costs them 10 cents, or it costs them 4 cents to make, and they sell it for 10 cents, right? So for every lollipop, let's see how much profit they make. 10 minus 4 and equals 6. So we know that they make 6 cents of profit per lollipop, or in dollars that would be $0.06 per lollipop, and we know lollipop represents N. So for per lollipop they make 0.06, and they had to spend $10 to advertise. That means that they're using their money, they're not gaining money, right? That means that we have to subtract that much. So we know our formula will look something like this. 0.06 N, or sorry, that kind of looks more like an H. 0.06 N subtracted by $10, right? It's going to be equal to P. So our formula should look something like this. And if we look down here, you can see that A fits this the best. It's exactly what we wrote down. Let's move on to question number 6. Nadia lives 11.4 kilometers from school and rides her bike to school every day. The equation D equals to 11.4 minus 0.6 T represents the relationship between D, her distance from school in kilometers, and T, her time spent traveling in minutes. If she leaves home at 8:05 a.m., what time will she get to school? Now, what we have to find out for this one is how long does it take for her to get to school, right? And the way we do this is we grab our total distance, 11.4, and then we divide it by 0.6 to get how. So we're basically asking how many times can I fit 0.6 into 11.4, and whatever the answer is the amount of minutes it takes, or the variable T. So T is going to be equal to 0.6 over 11.4 over 0.6, right? Now if we do this, we will get the answer of, let me erase our T. We'll get the answer of 19 minutes. So now we simply have to add 19 to 8:05. So 19 plus 5 is going to give us 24. And let's look down here. The best answer we have is 8:24. Let's move on to question number 7. The total cost of printing yearbooks is made up of fixed setup cost plus a cost per book. Graph A represents the total cost of printing the yearbook last year. Graph B represents the total cost of printing the yearbook this year. Now we have to look at this graph and we have to give the truth statement. The fixed setup costs for printing yearbooks last year and this year are the same. No, we know that the setup cost is a bit lower last year than it was this year. So you can cross this out. The fixed setup cost for printing yearbooks this year is lower than the fixed setup cost of last year. And we also know this is not true, because basically we know that it costs more to print every yearbook than it costs us to this year, right? But the setup costs more this year, right? So we can cross that out. The cost per book for printing this year is more than the cost per book for printing last year. And we also know that that is false, because per year, we are not spending as much. Or sorry, per book, we're not spending as much as we were spending last year. Because as you can see, it starts before, and then it goes like it gets higher. The cost gets higher as we make more books. So we know that it costs less to make each book now than it did last year, right? That leaves us with only one. The cost per book for printing last year is more than the cost for printing this year. And this is the true one. So thanks for watching the video, and see you next time.